Okay, let's just look at some angle theory here. We have two lines that intersect one another. And the intersection point is this central point here. And then we have some angles that we can see around here. We have A here, and B, and C, and D. What can we know about these angles? Well, let's say that C equals 60 degrees. So we're starting with C equaling 60 degrees. What can we say about angle A then? Well, angle A, or we can actually write it like this, with A with a little hat on the top as angle A. We know that these angle A and angle C are on a straight line. So A plus angle C equal 180 degrees. But we know that angle C actually equals 60 degrees. So we know that angle A must equal 180 minus 60 degrees, which is 120 degrees. So we now know that angle A equals 120 degrees. What about angle D then? Well, angle A and angle D are also on a straight line. So if angle A is 120 degrees, then angle D must be 60 degrees, because 60 plus 120 is 180. So we know that angle D must equal 60. And if angle D and B, they're also on a straight line here. So if angle D is 60, then angle B must equal 120 degrees. Because 60 plus 120 is 180. So what can we observe then about intersecting lines, the vertical angles, the angles opposite one another in intersecting lines? We can see that angle C is going to equal angle D. Opposite angles on an intersecting pair of lines are equal to one another. And likewise, angle A equals angle B, which in this case was 60 degrees and 120, but we wouldn't have even had to measure them. It wouldn't matter what number these angles would have been. So opposite angles like this are identical, and whichever way we're looking at it. Right, let's see what we can do then when it comes to look, and this is a very important fact to remember. So we have that angle A is going to equal angle B, and we have that angle C is going to equal angle D, the opposite angles. What are we going to be able to do here then? Here we have two parallel lines running, and they're never ever going to meet. They're carrying on at this distance apart throughout the universe. So what do we know then about angle A and angle C? Well, we can see that angle A and angle C are opposite angles. So the first thing we can say is that angle A equals angle C. What then can we say about angle A and angle D? Well, we can see that if this is a parallel line, if these two are parallel lines and this line is running straight through here, then angle A must also equal angle D, because the angle here from this intersecting line to that line must be identical, because these two lines are parallel to one another. So this line is meeting at the same angle here, so this angle must be the same. So we can also say here that angle A must equal angle D. So if angle A equals angle D, then angle C equals angle D. But angles D and B are also opposite one another. And we know that opposite angles are identical. So what can we say then? That angle D also equals angle B. So when it comes to parallel lines and intersecting angles, we can say that angle A equals angle B equals angle C equals angle D. And that must be equivalent for the other angles here as well. That if we were to call this one angle E, it would be equal to angle F, which would be equal to angle G, which would be equal to angle H. So these are some very interesting geometrical facts about angles that intersect one another.